So intercepts come up all the time. They're really, really important for us to understand. And they can be quite easy once you understand what's going on. We can obviously look at our graphs to find intercepts. So we can say, look, that passes through at 3, that passes through at 1.5. Happy with that? We have two types of intercepts. X-intercepts, which is pretty crazy, where it intercepts the x-axis. Crazy stuff. We've got these y-intercepts, and they're almost as crazy. You'll never guess so. Guess what they cross? They're good. The y-axis. Okay? So obviously in the name, we can see what axes we're crossing. It can be easy to mix these up, but because when we're finding these, tell me where every x-intercept in the history of x-intercepts has occurred. Every x-intercept has occurred at some point when y equals 0. What about every y-intercept? Where has it occurred? At x equals 0. Does that make sense? Doesn't make sense or not? If we come over to our graph here, right? This is the y-axis, correct? Where does the y-axis lie? On 0, on x equals 0. Does that make sense? So anywhere along this line, if I go from infinity that way, x equals 0, correct? If I do the same for the x-axis, well, what is the y value equal all the way along that? 0. Does that make sense? So I can find any intercept, because I could sketch these functions. But am I lazy?
Yes.
Mathematicians are, they don't like doing any extra work. So how could I avoid sketching these all the time? I don't want to sketch. I want to be given a function and I want to know where my intercept is. So if I get, give me any function, give me some numbers. Y equals 7 x plus 2. That's a pretty crazy function. I want to find the x and the y-intercepts. How can I do it? Let's start with the y-intercept, because it's even easier. How do I find the y-intercept? I don't want to draw a graph. I'm lazy. I'm so lazy. I refuse to draw a graph. I'm not drawing a Cartesian plane. I've done it. I've drawn so many of those these week. I'm over it. I can find it in 2 lines of working. Don't want to draw a table. I'm that lazy. No tables.
7 times 0 plus 2.
So what have I done? You're right, 100% correct. So Cooper said, so there's actually 3 lines of work, 7 times 0 plus 2 equals 2. I just need 1 line of work between that where I'm telling the person what I'm doing. What he's done is perfect. The x-intercept does, sorry, the y-intercept does occur at x, y equals 2. Yeah, for good working on it, yeah. You're right, though. In your head, you know it's just a back number, nothing wrong with that. But for working, I do need to show that. I need 1 line just to explain what I've done. What have I done? What's the difference between this line and this line? I've substituted what? X for? So the only line of work I need is let x equal 0. Yeah, yeah. If you wanted to be really good, you'd write finding the y-intercept, but again. Are we clear with that? So what's the take? If I find the y-intercept, what should I do? To find let x equal 0. Oh, sorry, that's the wrong one. Right idea, wrong one. I'm just going to write let y x equal 0. Are we clear with that? Now, I will give us one little, same equation. I'll just rub it out and do it somewhere I've got a bit more room. I might do it on the right hand side. Do it on the right hand side. So let's assume I've got my problem straight up again. I've got the same function. I get asked to find the intercepts of the following. I get y equals 7x plus 2 for my y int, just done my y int, but we'll go through it again. For y int, let x equal 0. Y equals 7 times 0 plus 2, y equals 2. Okay, if I wanted to find my x-intercept, what do I have to do? Let y equals 0. A little bit trickier here. Why is it going to be trickier? Because I'm going to have 0 equals 7x plus 2. Why is that trickier? Where was y? Y is by itself, isn't it? Is x by itself? So we need to get that. How do we get x by itself? There was a process, Charlotte, you should remember it from last semester. Starts with two words. We are rearranging. How do we rearrange? What's the process, Lauren? Reverse and opposite operations, correct? That's okay. It's the same. It's just a way, it's a process, that's all. You're learning it now. So what I've got to look at and say, what do I want to get by itself? I want to get x by itself, correct? So I like to put the first few times I do it, some way of saying that's what I want to get by itself. Now I ask myself, what are those numbers doing to the x? What's the 7 doing to the x? What's the operation? Rory, what do you reckon the operation is between the 7 and the x? Geez, Rory, you've got a very deep voice and your ability to project it over here is amazing. What about the 2? What's the 2 doing? What's that operation? Plus, so it's adding, correct? So we've got a times and an add. What was that trick before? We had a special name for it, I brought it up. Reverse omdas. Now, you'll never guess what that means. You know how bomb-dash we normally go this way? When we're rearranging, we go this way. So what do we hit first? Do we hit addition or multiplication first? We're going reverse. Addition. How do we undo an addition? Subtraction. So I'm just going to get rid of my box so it doesn't confuse you now. I want to get rid of this 2. So the way I get rid of a plus 2 is I? Minus 2. Can I do it just to one side? Have to do it to both sides. So I'm minus 2 from both sides. Does my equal sign still work? Have I done anything to break my equal sign? So I'm all good. What happens to the 2's? They cancel out. Now I'm left with 7x equals 0 minus 2, which is negative 2. Does that look easier? Are we one step closer to where we want to be? What's stopping the x from being by itself? Lynn? 7, what's it doing? Yeah, which operation though? Timesing. How do I do a times now? What's the opposite of times? Divide, so we divide both sides by 7. What happens to the 7's on the right? And we're left with x equals negative 2 over 7.